for my first one here, we have 1 over 1 plus x. I need this form from 1 over 1 minus something. Well, I can simply write that as negative x. 1 minus negative x is positive x. And then, well, I've now got that good form. That simply becomes from n equals 0 to infinity of negative x raised to the n power. And now, you've got the power series representation for 1 over 1 plus x. Again, the absolute value of negative x needs to be smaller than 1. But the absolute value of negative x is equivalent to just plain O absolute value of x smaller than 1. You can factor out the negative 1 and the absolute value, but the absolute value of negative 1 is just positive 1. So we'll simply get that x need, okay, positive 1 and negative 1. That will be the interval of convergence. Okay. Here's the next example. 1 over minus x cubed. Okay, we're just subtracting away this x to the third power. So, again, all I have to do, once I have this in this form, good, it says, whenever I'm subtracting away, I simply raise that to the nth power. Well, in this case, I'm subtracting away x to the third. Okay? And sometimes, you'll see, write this as n equals 0 to infinity of x to the 3n. Okay, same thing, this is going to help us. We're going to use this to get our interval of convergence. So it's the absolute value of x cubed needs to be smaller than 1. Okay, you can take the cube root basically, and again, you'll basically just get the absolute value of x need to be less than 1, so you'll get the interval of convergence. That x needs to be between negative 1 and positive 1. That will be your interval convergence. Okay, thank you.
I'll start with an example that shows where complex numbers come in handy, or not just handy, but are in fact unnecessary. 2x squared plus 9 equals 5. Take a look at this problem. This is an ordinary algebra problem, so let's try to tackle it using the basic techniques of algebra, which basically says we can do pretty much anything we want to do to the equation as long as we do exactly the same thing to each side, so it stays balanced. Now my goal here is to solve for x. I want to isolate x. I want to manipulate the equation so it eventually say x equals something, so clearly I need to subtract 9 from each side, and then plus 9 and negative 9 cancel out. That leaves me 2x squared on the left, and on the right I have 5 minus 4, which is negative 4, and then I divide by 2 on each side, and the 2's cancel, and I'm left with the x squared equals negative 2. And then to solve for x, to get x completely isolated, I need to take the square root of both sides. So on the left, the square root of x squared is just x, and on the right, when I take the square root of negative 2, I end up with plus or minus. Don't forget the plus or minus the square root of negative 2. Now at this point, you might think that's the problem, we can have negative numbers inside the radical and in algebra 1 classes. You typically get to a situation like this and we say that there's no real solution. And the terminology here is meaningful when we say there's no real solution. We mean there's no real number that is a solution to this equation. There's no real number that we can plug in like the thing for x and end up with negative 2 as a result. It turned out there's no real number solution, but there is a complex number solution. And when you think of real number, just think of a number line. So imagine 0 here. We put our little trick marks, but the number don't have to be right. In the tick marks, remember, you could have number 2 or the number negative 1, 1/2, or pi. Any number on the number line is a real number. That's why we call it a real number line. That's basically the definition of a real number. Is any number that exists on the real number line. And there's no number on here that solves this equation, because when you get right here, you realize nothing squared is ever going Haba. Sulit.
Find the inverse matrix of this 3 by 3 given equation. We'll arrive this with 0, multiply to negative 1, 3, 1, 4, minus 0, 2, 3, 1, 4, plus 1, 2, negative 1, 1. We'll have an equation of 0, minus 0 plus 1, multiplied by 2 plus 1. The answer equals to 3. Then, how do we arrive with those matrix? 2 by 2 matrix. At first, just cover this part and this part, and we'll have one gonna lie is negative 1, 3, 1, 4 is bound. Then 2, 3, 1, 4. Just cover this top part and the middle part. You get this and this. Just cover the top part and the outermost right lane. So on and so forth, and you will arrive with those 2 by 2 matrices. Then the sign, just alternate positive, negative, positive, negative, positive, negative, positive, negative, positive. Then at first 2 by 2 matrix, we have a negative 7 answer. How we arrive with those negative 7? Negative 1 times 4 equals negative 4 plus negative 4 plus negative 3 equals to negative 7. Then negative 5 equals to 2 times 4 equals to 8 minus 3 with a equals to 5. Then use this negative sign. So negative 5. Then 2 times 1 equals to 2 minus negative 1 equals to positive 3. Then positive sign equals to 3. So on and so forth, and you will just use the technique so on and so forth, and you would arrive with this 3 by 3. Then just copy the first part to arrive then the horizontal axis, this horizontal axis, put it on the y-axis. So let's see 1, negative 1 and 0, put it in the second lane, or y-axis 1, negative 1, 0, 1, 2 and 0, 1, 2 and 0, just like this. Horizontal axis to vertical, then multiply by it by 1/3, and this is the inverse matrix answer. Find the Laplace transformation of this given. We have a equation 0 to infinity. Take our function, we have to multiply by e to negative st and e raised to t. So I'm going to rewrite this first off. So this is 0 to infinity. Add the exponents. I could write that as t minus st, then again integrating with respect to t, and I think what I'm going to do is simply factor out t, and then I have the quantity 1 minus dt left over. And remember, from proper integrals we have to simply get rid of the infinity. We'll turn another variable, call it letter b, goes to infinity, function e to the t multiply 1 minus s dt. To have integrate in this problem, let s equals to 1, the limit of b to infinity, integral of 0 and b, then we have to integrate 1 dt. The limit of b to infinity. You could notice we compute this we'll simply have infinity well we would have b minus 0 and notice as b goes to infinity as b, this is simply going to equal infinity. So this improper integral is actually going to diverge and s equals 1. So we calculate the Laplace transformation. We were going to exclude the value from the domain because it yields an improper integral, and somehow those are not going to be interest to us. Okay.